Question 8 asks you to draw the skeletal formula for each of the following. And you want to start by looking at the backbone. Now the backbone is going to be this part right here, the part that comes after all of the YLs. Remember that YLs tell you that you have a branch. So after that is our backbone, and the prefix for our backbone is hept. So hept means that you have 7 carbons. So I'm going to write 7 carbons out. 1, 2, 3, 4, 5, 6, 7. And then the infix is AN. And AN is telling you that you have all single bonds. So in between these carbons, I'm going to put all single bonds. And since I know carbon needs to have 4 bonds, all of these need to have 4 single bonds. So I'm going to fill these in so they all have 4 single bonds. Okay, the E suffix tells us that we have only hydrogen and carbon on this. So except for our branches, everything else is going to be a hydrogen. Now before I fill those hydrogens in, let me think about the branches. We have one branch, and the branch is 3-methyl. So if we're thinking about the branch now, the branch is this 3-methyl part. The 3 is telling you where the branch attaches to the backbone. And so you will want to number the backbone. Because we're creating the molecule, we can number it however we want. So I'm just going to number it left to right. 1, 2, 3, 4, 5, 6, 7. And the branch is going to be coming off of carbon 3. All right. The prefix for the branch is meth, and meth means you have 1 carbon. So coming off of carbon 3, I'm going to have a branch of just 1 carbon. Now I could have put that carbon going up. I'm putting it down, because these single bonds can rotate. Those are actually the same thing. Okay, so it's meth. And then the YL just tells you that you have a branch. That's the suffix for a branch. Okay, so now we know that this carbon in the branch also has to have 4 bonds, and all we have to do is fill in the hydrogens. We know that this is a hydrocarbon, so we'll fill it in with a bunch of hydrogens, like so. Now this is the structural formula for this molecule. We could also draw the skeletal formula, and that would just focus on the carbon chains, and the hydrogens would be implied. And so the way you would do that is you would have a carbon, draw just a dot for the first carbon, and then you would draw a zigzag line. So each point of the zigzag is going to represent a carbon. So you have the first one that you start with the dot, then 1, 2, 3, 4, 5, 6, 7. So each of these points are carbons. All of the hydrogens are implied, and we want to put the branch on the 3rd carbon. So this is 1, 2, 3, 4, 5, 6, 7. This branch is coming off of carbon 3. So off of carbon 3, we'll have another carbon, and the carbon would be at the end there. So these are 2 ways of drawing 3-methyl heptane. The top way is the structural formula, and the bottom way is the skeletal formula. And they would both be correct. All right, let's try to draw ethyl cyclopentane. Now, focus on the backbone first, and the backbone always starts after the last YL. So this is going to be cyclopentane. The prefix cyclo tells us that we are going in a ring. The prefix pent tells us that we're going to deal with 5 carbons. A 5-carbon ring looks like a pentagon, and so you can sort of draw the carbons at each vertex of that pentagon, each point of the pentagon. The infix AN is telling us that we're dealing just with single bonds. So I'll connect all these carbons with single bonds, and I know carbon has to have 4 bonds, so these have to have 2 other single bonds each. Then the suffix is E, so we're dealing with a hydrocarbon. So when we finally have to fill bonds in, we're going to fill it in with hydrogen. But first, let's draw our branch. So that's the backbone. The branch is ethyl, and you know it's a branch because branches always end in YL. The prefix here, F, means you have two carbons for F. Now it doesn't tell us where to put it, and it doesn't give a number, for example. And so what that means is we can put this two carbon branch anywhere. We can attach it to any of these carbons. I'm just going to attach it to this one on the top right. So one carbon and a second carbon. We know these have to have single bonds, and these carbons also need 4 bonds. Now, because the suffix is E, and the YL, again, is just telling us we have a branch. Because the suffix is E at the very end of this, we're going to fill all of this in with hydrogens. So at the end of all these bonds goes a hydrogen. So that's one way of drawing ethyl cyclopentane. Another way of drawing it would be to draw the skeletal formula, and for that, you could draw each of the carbons as a point. So that would be ethyl cyclopentane. Let me just make that bond there a little straighter. So each of the vertices here is a carbon. We have just single bonds between them, and then we have a 2-carbon branch coming off there. So those are both correct ways of drawing ethyl cyclopentane. Okay, let's try to draw bromocyclobutane. And first, focus on the backbone. Now here we have a weird branch, bromo. That's a type of branch that we haven't seen yet. The halogens are in group 7A, and sometimes they are branches on hydrocarbons. So group 7A, if you look at the right on the periodic table, it goes fluorine, chlorine, bromine, and iodine. And when you make these elements branches, you replace the INE at the end with an O. So for example, F is fluorine. But when it's a branch off of a hydrocarbon, you take that INE off and you replace it with an O, and it would be called fluoro. Cl is chlorine. But when it's a branch off of a hydrocarbon, you take the INE off and you add an O. Br is bromine, but when it's a branch on a hydrocarbon, you take the INE off and you add an O. And I is iodine, but when it's a branch on a hydrocarbon, you take the INE off and you add an O. So these are the branch names for the halogens in group 7A. And you can see that we have bromo right there. Bromo is telling us that we're going to have bromine as a branch on this backbone. So that's one branch. We might not have recognized it as a branch because we didn't see the YL, but it doesn't have a YL because it's not a carbon branch. Remember, carbon branches always get that YL. Okay, so now that we know that's a branch, we know that the rest, everything after it, is the backbone. The prefix cyclo here is telling you that you're going in a ring. Bute, the prefix bute, is telling us that we're dealing with 4 carbons. So a 4-carbon ring, that would look like a square. So I'll draw those 4 carbons there. The infix, AN, is telling us that we have all single bonds, so I'll connect these all by single lines. And I know carbon needs 4 bonds, so I'll fill those in with more single bonds. And the suffix E is telling us that we have a hydrocarbon. So after I fill in all the branches, I'm just going to fill in all the other bonds with hydrogens. So that's the backbone. Now back to our branch, bromo. So bromo tells us that our branch is just bromine, and we can put that wherever we like. So they don't give us a number. They don't give us any number here in front of the bromo, so we just put it anywhere. I'm going to put it right there. You could have put it at the end of any bond. And that takes care of that branch. Now, because it's a hydrocarbon, we just fill all the other bonds in with H's. And that would be bromocyclobutane. That's the skeletal structure for it. If you wanted to do that's the structural formula. If you wanted the skeletal formula, skeletal structure, you could draw the lines. The hydrogens are all implied. Each chink in the chain, each vertex is a carbon. And off of this carbon right here, you would just have that bromine. So these are both ways of drawing bromocyclobutane. All right, 2,3-dichlorohexane. Now again, you see that this is a branch. Chloro, that's when the name for chlorine when it's a branch. And so the backbone is everything after that, hexane. Our prefix here is hex, and that tells us that we're dealing with 6 carbons. So I'm going to draw out 6 carbons. 1, 2, 3, 4, 5, 6. The infix is AN. That's telling us that we have all single bonds. So I'm going to connect these all by single bonds and make sure that all the carbons have 4 bonds, 4 single bonds. And the suffix is E. And the E is telling you that you have a hydrocarbon, which means after we fill in the branches, everything else is going to be hydrogen. So that's our backbone. Let's look back at our branches. The first thing you see here is a 2 and a 3, and that's telling you where the branches go. So in order to put those in the right place, we have to number our chain. Since we're creating it, we can number it however we want. I'm going to number it left to right. 3, 4, 5, 6. Okay, off of carbon 2, I'm going to have a chlorine. So I'll put that here. You could have written it on top. It wouldn't have made a difference. And on carbon 3, you'll have another chlorine, right? We're adding 2 chlorines, dichloro. So on carbon 3, another chlorine. And again, you could have put this chlorine going on the top of this molecule. It would have been the same molecule. So that takes care of our 2 branches, 2 chlorine branches, and the rest, because this is a hydrocarbon, the rest is just going to be hydrogen. So we can fill those in like so. So that's the structural formula, but if you wanted the skeletal formula, draw a dot for the first carbon, so that's 1, 2, 3, 4, 5, 6. If you want to number it so that you make sure you're doing the branches right, it'd be like so. Off of carbon 2 and 3, you have the chlorines. So carbon 2 has a chlorine and carbon 3 has a chlorine. And when you're drawing branches coming off of these skeletal structures, the branches usually go in the same way that the point is going. So notice this point here is kind of going up, and so the chlorine is pointing up. On carbon 3, the point is sort of going down, and so the chlorine is pointing down. That's not a hard and fast rule, but it's a sort of rule of thumb. And so these are both ways of drawing 2,3-dichlorohexane.